All right, so let's talk about the period of a trig function. Okay, so what we mean by period is the distance along the theta axis that it requires for the graph to go through one complete cycle. So for instance, if I start at this point and I trace the graph here and all the way to here, I've completed one full cycle. Notice after that, the graph just starts over and it repeats that pattern. So I go up, down, back up to the theta axis, and then I start the whole pattern over, do it again, and I do it again forever and ever and ever. And the same this way, I would go same pattern forever. So to complete one full cycle requires this distance right here. It requires from 0 to 360 degrees. So the period will be 360 degrees. It requires 360 degrees for the graph of sine to go through one complete cycle before it starts over and repeats. Notice that you could start counting from any point. So say I started counting at the 90 degrees. How long would it take to go through one full cycle from here? So I'm starting up here at the top, going through the theta axis, down to the bottom, theta axis, all the way back to the top, and then the cycle repeats. So that would be from 90 to 450 degrees, which is also 360 degrees. So the period is 360 degrees. We can also write that in radians, of course. That would be 2 pi radians. All right, let's look at the period of tangent. How many degrees or radians are required to go through one complete cycle? So notice the pattern that occurs here. We have this, and this. So the distance to go through one complete cycle here would be this distance. That's from negative pi over 2 to pi over 2. So this distance would be a full pi. So the period would be pi. Or you can look at it here from half a pi to 3/2 of a pi would be 2 pi over 2 or pi. And of course you could write that in degrees. That would be 180 degrees. All right, let's graph this function, sine of 2 theta. All right, so let's just plug in some points. Let's plug in 0 degrees for theta. So if I put 0 degrees in, 2 times 0 is 0. I have the sine of 0 degrees, which would be 0. Now let's put in 90 degrees. So if I put in 90 degrees, 2 times 90 is 180. So I'm doing the sine of 180 degrees, which would be 0. Let's put in 180 degrees. So if I put in 180, 2 times 180 is 360. Sine of 360 is 0. So let's think about what's going on here. So what numbers, so I'm plugging in the theta values and I'm multiplying those by 2. We usually like to plug in 0, 90 degrees, 180, 270, and 360. In order to plug those in, we should plug in well-chosen numbers for theta so that we get those. So what I mean is, let's plug in 45 degrees. Why do I do that? Because if I put in 45 degrees, 2 times 45 is 90. That's one that I like to plot. So put in 45 degrees, 2 times 45 is 90. Sine of 90 degrees is 1. And then 90 degrees we've already got, that's 0. Let's do 90 plus 1, that's 135 degrees. So if I plug in 135 degrees, 2 times 135 is 270, and that would be -1. And 180 I've already done. So notice what happens is I've compressed that cycle of sine function that usually goes from 0 out to 360. I've compressed it into 180 degrees. And then we could carry on from there. If I plug in this next one, this would be, let's see, 180 plus 45 is 225. 2 times 225 would be 450. The sine of 450 degrees is, see, it's all the way around the circle once and 90 more, so the sine would be 1. And of course, you see what's happening there. Next one would be here, down here, and back to that. That, and then the same thing would occur over here if I plug in negative 45 degrees. 2 times negative 45 is negative 90. The sine of negative 90 is negative 1, so that's down here, and here, like that. All right, so what happened? What did this 2 do to the graph? Well, it took the original sine graph and it compressed it horizontally, squeezed it together like a slinky. So now, what is the period? What's the period now? So to go through one complete cycle requires, start here at 0, up, down, back to here. So my period would be this distance from 0 to 180. So my period now would be 180 degrees. Or in radians, that would be pi radians.